Hello, this is the last part of our lesson 24. We're just going to do some hopefully quick examples of more complex fractions. And so we are going to revisit the idea that we have to find values that make the denominator 0, because we actually have to exclude those values. Because we learned from previous lessons that anything over 0 is considered undefined. That means that our expressions will work if there's a value that does not make the expression undefined. So we have to call out anything that would make the denominator 0. So I have here a complex fraction, and it looks really weird as a fraction in a fraction. So immediately I'm going to rewrite it as something, the dividend with the divisor, the divide sign, and then the divisor, 2x over x minus 4. Now, here's what we have to consider. We cannot have a 0 in this denominator. We cannot have a 0 in this denominator. We also cannot have a 0 in this denominator. In this big fraction, this fraction within a fraction, we cannot have a 0 in this denominator. Now, if the divisor is equal to 0, that means that the numerator has to equal to 0, because you have to think, how would this become 0? If the numerator is 0. If the numerator of this fraction, the divisor, is 0. So let's call out any values that will make either the dividend or the divisor or the entire expression undefined. X cannot equal 3. That's from this one. X cannot equal to 4. That's from this one. And imagine if x was equal to 0. If x was equal to 0, let's just plug it in. Let's just plug in if x was equal to 0. We'd have 8 over 0 minus 3 over 2 times 0 over 0 minus 4. That simplifies to 8 over negative 3 over 0 over negative 4. 0 over negative 4 is equal to 0. Then we'd have 8 over negative 3 over 0? No, that's undefined. Therefore, we cannot have the numerator of our divisor equal to 0 as well. I'm going to get rid of this. Sorry. You can pause the video if you need to copy this down. Okay. Other things that can't equal to 0. So x can't equal to 4 and x cannot equal to 0 because it will make the entire expression undefined. From this point, we can do our algorithm for division, and we have x minus 4 in the numerator and 2x in the denominator. I multiplied by the reciprocal, took the reciprocal of this. Now I just multiply across. 8 times x minus 4 over 2x, x minus 3. There is a common factor between 8 and 2 that I can take out and cancel, and I get left with 4x minus 4 and x minus 3. Okay, I wrote in some text down here about a little bit about what the division and the undefined values mean, and you can pause the video here, read it, summarize it in your own words, add it to your notes. What you are also adding to your notes is down here, and to summarize, this was their summary, and now what you get to do is rewrite it in your own words. The expression a over b divided by c over d is undefined when either the denominator, this is the denominator for the dividend denominator, So is d. D is the divisor denominator. And then the c value is the divisor numerator. And none of these three values can equal to 0, otherwise the whole expression is undefined at some point. Okay. Moving on, we have two examples, and we're going to find the quotient and reduce the lowest terms. what we're also going to do is we're going to call out any of the values that make this expression undefined. So I'm going to take this complex fraction and I'm going to rewrite it. I'm just going to take this big fraction and rewrite it into something that looks more familiar to me. I need a division symbol, and then I have x squared minus 9 over x squared plus 5x plus 4. Okay, I'm going to factor and then evaluate what values of 0 make any of these expressions undefined. So I'm going to use my mental math. I have x minus 2, x minus 3 over x plus 4. And then divide symbol. I have x minus 3, x plus 3. Then I have x plus 4 and x plus 1. Great. So now I have to think to myself, x cannot equal to negative 4. X cannot equal to negative 4. We have that one. X also cannot equal to negative 1. And I have to look at the numerator and the divisor. X cannot equal to negative 3, and x cannot equal to positive 3. Positive 3, x would be 0 here. Negative 3, x, this factor would be 0. Okay, at this point, I'm going to rewrite. I'm going to do my algorithm where I multiply by the reciprocal. So I have x minus 2, x minus 3. I'm going to zoom in. Zoom in. No, it's not gonna let me zoom in. Okay, well, I thought it was gonna let me zoom in. It won't. And then x plus 4 times, I'm going to take the reciprocal of the divisor, x minus 3 and x plus 3. Now I'm going to rewrite, I'm going to combine all my terms and then rewrite my product so that I can line up my factors. X plus 4, x plus 1. I'm looking at my denominator. There's an x plus 4. I have an x minus 3. And then I have this x plus 3 that doesn't fit in. So I go through. This is equal to 1. This is equal to 1. And now it's equal to x minus 2, x plus 1, and x minus plus 3. And we check. What other value makes this denominator 0? Minus 3. Good. We have x minus 3 already. Last example, here's an example if you need to pause and copy it down. Last example, we're going to put multiplication and division together. And the first thing I need to do is I'm going to factor this before I call out the values that need to be avoided to avoid division by 0. So I'm going to factor this numerator, x minus 7, x plus 7. This denominator here, I'm going to show you my scratch work. So in my scratch work over here, scratch, I have 3x squared minus 24x plus 21. So there's a greatest common factor here. I'm going to take out a 3, and I'm left with x squared minus 8x plus 7. Oh, all of a sudden, this is a lot easier for me to factor in my head. I know that this is x minus 7 and x minus 1. Okay, I'm going to put it back over here. 3, whoop, come back. 3, x minus 7, x minus 1 times negative 2x. And over here, I'm going to factor a negative 1 to get negative 1 times x plus 1 divided by x plus 7, whoop, x minus 1, x plus 1. Okay, so x cannot equal all the values that x cannot equal. It cannot equal to positive 7. X cannot equal to, is this a 1? Right, positive 1. It cannot equal to negative 1. And it cannot equal to positive 1. Have that one already. And negative 1. We have that one already. And the numerator of the divisor, x cannot equal to negative 7 either. Okay, so now let's do the division algorithm where I'm going to multiply and divide from left to right. That's what PEMDAS tells me to do. So I'm going to write a big bar here. I have negative 2x, x minus 7, x plus 7 over 3. This negative 1, I have a negative 1 over here. X minus 7, x minus 1, and then x plus 1 times, I have to flip this expression over to get x minus 1, x plus 1 over x plus 7. And now now that everything, I can continue to multiply. There's some things that I can simplify already, like this. I can also take out a negative from here and cancel it out with this negative. So I am left with, I'm going to combine the rest of my factors. So I have 2x left. I have a 3. I have x plus 7. I have x minus 1, x plus 1. And conveniently, I have all those factors in my denominator as well, x plus 7. And I can cancel away. Cancel. Simplify to 1, simplify to 1. And I am left with 2x over 3. Check. There are no other variables that would make this denominator 0, so these are still all the values we have to exclude, and this is our fully simplified answer. Okay, write your summary at the bottom. Summary. If you have questions, make sure you write down your questions and go through these examples and annotate. What surprises you? What do you need to be careful of? What do you still have questions on? Or what do you know completely? Go through and mark up your example. Okay. That's it. Bye.